In this video, we want to do some more examples of the integration by parts. Let me remind you the integration by parts formula. Integral of u dv is equal to uv minus integral of v du. This is the formula of integration by parts. For choosing u in the integration by parts, if you remember, we learned this trick, LIATE acronym, which L stands for logarithmic function, I for inverse trig, A algebraic, T trigonometric function, and E exponential function. This is the order that we choose u. Integral of x squared ln of x dx. We want to find this integral. Because x2 is an algebraic function and ln of x is a logarithmic function based on the LIATE trick, because L appears in this list before algebraic, so we choose the logarithmic part as u. So we choose u as ln of x, and the other part of this integral is dv. So we choose x squared dx as dv. Don't forget, when you choose dv, dx is always part of the dv. Now, as usual, we have to take derivative of u. du, derivative of u is 1 over x, and don't forget to multiply it by dx, because du is differential of u. And from dv, we have to integrate to find v. v will be equal to x to the 3 over 3. Integral of x2 dx is x to the 3 over 3, based on the power rule. Now everything is ready to use the integration by parts formula for finding this integral. Integral of x2 ln of x dx is equal to uv, u is ln of x times v, which is x to the 3 over 3, ln of x times v, which is x to the 3 over 3, minus integral of v, which is x to the 3 over 3, times by du. Derivative of u, du is 1 over x dx, so times by 1 over x dx. Now if we simplify x from the bottom with one of the x from the top, we get to this expression. Let's write this part again. X to the 3 over 3 times ln of x minus integral of x2 over 3 dx, or integral equals to this expression. Now for finding this integral, you can pull out 1/3 and put it outside of the integral first. X to the 3 over 3 ln of x minus 1/3 integral of x2 dx. Again, integral of x2 dx is x to the 3 over 3. So we have x to the 3 over 3 ln of x minus 1/3 times x to the 3 over 3 plus c. Now if we multiply x to the 3 over 3 by 1/3, we can write our final answer in this form. X to the 3 over 3 ln of x minus x to the 3 over 9 plus c. Let me show you another example. Integral of x times e to the 2x dx. In this example, x is algebraic function and e to the 2x is exponential function. And because in this list algebraic function appears before exponential, so we choose u, the algebraic part of this expression. So we choose u as x, and dv will be the other part of this expression. From u, as usual, we have to take derivative, and derivative of x is 1, so 1 dx or dx. And from dv, we have to integrate. Integral of dv is v, and integral of e to the 2x is 1/2 e to the 2x. Maybe you wonder why integral of e to the 2x is 1/2 e to the 2x. Let me remind you that integral of e to the x dx is e to the x plus c. If a constant multiplies by x in this formula, say we have e to the ax dx in general, the answer would be 1 over a e to the ax plus c. So if we have e to the 2x dx, the integral would be 1 over 2 e to the 2x plus c. And note that this rule is valid not only for this case. In any formula of integral, for example like this, integral of cosine of x is sine of x. If you had cosine of ax, the answer is 1 over a sine of ax. For example, integral of cosine of 3x dx is 1/3 sine of 3x plus c. And for simple integrals like this, you don't need to do any u substitution. Of course, you can find integral of cosine of ax dx with the u substitution by choosing u as ax. But doing u substitution takes time, but with this way, you can find integrals faster. Let me show you another case. Let me show you another example. For example, we know that integral of secant squared of x dx is tangent of x. So, integral of secant squared of 5x dx, for example, can you guess what the answer would be? 1 over 5 tangent of 5x plus c. Let's back to our question. Now we use the integration by parts formula for finding this integral. The integral equals to u times v. U is x and v is 1/2 e to the 2x. So u times v is x times 1/2 e to the 2x minus integral of v is 1 over 2 e to the 2x times du, and du is dx. Note that you can rewrite this expression in the form of 1/2 x e to the 2x, and if we pull out this 1/2 from the integral, we get 1/2 e to the 2x dx. So our given integral equals this. Integral of e to the 2x dx is again 1/2 e to the 2x. If we multiply this by 1/2 outside of the integral, the answer would be 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And this is the answer of this integral. Let's try another example. Integral of x secant squared of x dx. X is algebraic and secant squared is a trigonometric function, and so we choose u to be x and dv secant squared of x dx. If we take derivative of u, derivative of x is 1 times dx, and v is the integral of secant squared. We know that integral of secant squared is tangent of x. And now if we use the integration by parts formula, this integral equals to u times v, which is x times tangent of x minus integral of v, integral of tangent of x times du, and du is dx. Whenever you had integral in the form of f prime of x over f of x dx, this integral equals to ln of absolute of denominator. Based on this formula, if the derivative of the denominator appears in top, f prime of x is derivative of f of x. So if you had an expression in denominator and derivative of that denominator was in top, the integral of that function, the integral of that expression is equal to ln of the denominator, ln of the expression in denominator. For example, if you want to find integral of 2x over x2 plus 1 dx, because derivative of the denominator, derivative of x2 plus 1 is 2x, appears in top, this integral is equal to ln of the denominator. Another example, if you want to find integral of cosine of x over sine of x dx, the answer would be ln of absolute of sine of x plus c, because derivative of sine of x is cosine of x, derivative of the bottom appears in top, the answer is ln of sine of x plus c. Another example, suppose you want to find integral of e to the x over e to the x plus 2 dx. Derivative of the expression in the denominator is in top, so this equals to ln of e to the x plus 2 plus c. Note that in this case and in this case, the reason that I am not putting absolute around these expressions is that x to the 2 plus 1 and e to the x plus 2 are positive expressions, and it's not necessary to put absolute around this expression. But if you like, you can put absolute around these expression as well. Suppose you want to find this integral with this method. Because the derivative of the bottom, x to the 3 plus 1, is 3x2, but in the top we have only x2, we can multiply a constant in the numerator, a 3 in the numerator, and we can put reciprocal of that number outside of the integral. Now we have derivative of the bottom in the top, and because derivative of the expression in the denominator is in the top, we can use this trick, and so this equals to 1/3 ln of absolute of x to the 3 plus 1 plus c. Now let's find integral of tangent of x dx. Tangent of x is sine of x over cosine of x. Derivative of cosine of x is negative sine of x, but in the top we have only sine of x, so we have to put a negative in the top, and to cancel that negative we put a negative outside of our integral. Now that we have the derivative of the bottom in the top, we can use this shortcut, and the answer is negative ln of absolute of cosine of x plus c. So integral of tangent of x is negative ln of absolute of cosine of x. So the answer of this integral is x tangent of x. This minus here cancels with this minus here, so we have plus ln of absolute of cosine of x plus c. Now look at this integral, integral of e to the x times by sine of x dx. This integral is one of the most famous integrals that we can find with the integration by parts. Here e to the x is exponential function and sine of x is trigonometric function. And because in this list t appears before e, we choose u as sine of x, and the other part, e to the x dx, will be dv. But actually, in this trick, t and e are interchangeable. So in this case, you can choose e to the x as u and sine of x dx as dv. But let's follow our rule and choose trigonometric as u and the other part as dv. So we choose u sine of x and dv e to the x dx. If we take derivative of u, derivative of sine of x is cosine of x, and if we integrate dv, v is e to the x, because integral of e to the x is e to the x. Now if we use the integration by parts formula, this integral is equal to u times v. U is sine of x, v is e to the x, so u times v is sine of x times e to the x, or e to the x sine of x, minus integral of v, v is e to the x, times du, and du is cosine of x dx. For finding integral of e to the x cosine of x dx, it seems that we have to do integration by parts again. Similar to the previous part, we choose the trigonometric part as u, and dv is e to the x dx. So du, derivative of u, is negative sine of x dx, and v is e to the x, and so this equals to e to the x sine of x minus now for finding this integral we use integration by parts formula. U times v. Note that u now is cosine of x and v is e to the x. So uv is e to the x cosine of x minus integral of v, which is e to the x, times du, and du is negative sine of x dx. If we cancel this negative here with this negative outside of our integral, so we have plus here e to the x sine of x dx. Let me rewrite this in a better form here. Integral of e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x minus, note that this minus is for all of the bracket, so we have minus integral of e to the x sine of x dx. As you can see here, after doing integration by parts twice, from the original integral exactly we get to the same integral with a negative sign. Now maybe you think it seems integration by parts doesn't work for finding this integral, but actually if you notice, almost we are done. You just need to move this integral here to the left and add it to the original integral. It becomes double, and then solve it for the integral. Before I do that, let me ask you a question, a very simple question. How you are solving an equation like this, a equals 10 minus a? For solving such an equation, simple equation, we move the unknown to the left and we get 2a equals 10. And then by dividing by 2, we say a is 10 over 2, which is actually 5. We want to do here the same thing. We want to move this integral, say this is a, to the left because this is also a. And if we move this a to the left, it becomes 2a. So if we move this to the left, we have 2 integral of e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x. And now if we divide both sides of this relation by 2 to get rid of these 2, we get to the answer. Integral of e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x over 2 plus c.